Got a couple more things to cover here. The first one is the law of sines, which is lesson 14.4. And we're going to use the law of sines to help us find the sides and angles of triangles that aren't right triangles. So we can actually figure out sides and angles of triangles that are obtuse or acute. They're not right. We won't be using any SOHCAHTOA, no Pythagorean theorem here because we're not dealing with right triangles. Now, in order to accomplish this with the law of sines, we need to know 3 of the 6 things. There are 6 things. There are 3 angles and 3 sides. We need to know one side, an angle across from it, and then any other bit of information. It could be a side or it could be an angle. I've got the formula right here for the law of sines. Sine of A over A equals sine of B over B equals sine of C over C. And you can just do 2 at a time. So if I was going to try to put A and B together, I would look like that. Sine of A over A equals sine of B over B. Okay, so I had some work up there to get rid of. You could also flip these over. If it's helpful, you could certainly say A over the sine of A is the same thing as side B over the sine of angle B. Sometimes it's better to write them that way. Generally speaking, if I'm looking for the side, if I'm looking for a side because I know 2 angles, I'm going to use this way. If I'm looking for an angle and I know 2 sides, I'm going to use sine on top. Now when you draw the triangles, they don't have to be perfect, but it's kind of helpful, I think, to try to get a triangle that's pretty close to what we're looking at. So what I've set up above there, I kind of skipped over, but I'll show you right here, is start with a side that you're given, and this one I'm only given one side, A is 5, and put that down low. Start with that as your base. After that, hopefully you've got an angle that would connect to that side. And I do. The angle that would connect to that side would be the 52. 25 does not connect to the angle A. That has to be, or to side A. That has to be across from 5. So I'm going to use the 52. So now what I'm going to do is try to come up with about a 52-degree angle. Oh, I don't know, something like this. Something a little steeper at 45. I don't know how long that side's going to be. I just know that this is supposed to be 52 degrees. Now, angle A is right up here. This would be angle A. And I want angle A to be 25. Again, I don't know how long that side was, but I do know that if I wanted this to be my 3rd side, that does not look like 25 degrees right there. So I'm trying to make it fairly close to accurate, just so I'm comfortable with my answers. It looks to me like I'm going to have an obtuse angle. Well, I know I'm going to have an obtuse angle, right? Because 25 and 52 are 77. So this other angle, I know what it's going to be. So I could have figured that out too. I will need that later. I might as well get it right now. I know that this angle would have to be 103. So that would be another thing you could figure out to help you draw your picture of your triangle. Get that 3rd angle right away, and you can say, all right, I got a better idea what it should look like. I got to go past 90. I got to get an obtuse. Okay? All right, so this was angle C. That means that side C is going to be here, and this is angle B. Side B is going to be over here. I'm going to find a side, so I'm going to use the one that had the sides on top. So I'm going to use like A over sine A equals B over sine B. Well, I know that this side 5 goes to this angle, so that's the relationship I'm going to use. I'm going to say 5 divided by the sine of 25 has to be the same thing of, well, if I was going to find angle B, or side B I should say, side B, I would say it has to be B over sine of 52. Now to find B, all I need to do is actually divide the 5 over sine 25 and then multiply the sine 52 over. So I would divide like this in my calculator. I would multiply by sine 52, and that's what b is going to equal. So it's calculator work from here. I can get my calculator up here. Make sure your calculator is in degrees. I had a problem with that earlier. I used a different calculator here, and I forgot I got a weird answer. I'm like, okay, that doesn't make any sense. Must be in radians. So I need to do 5 divided by sine 25. Sometimes you might want to close that out every time. Otherwise, if I had pressed equals right there, that'd be okay. I'm seeing people not close out the parentheses, and they're running into trouble. They need to take that times sine 52. There's nothing after the 2 here, so I mean I could or close it out, or I don't have to. I'll get the right answer. So that side is 9.32 approximately. I mentioned in a previous lesson that you might want to store that as an x or some variable in case you need to use that to come up with an answer. But I'm not using it to come up with an answer, so that's not going to be an issue. I know that b is about 9.32. I'm going to find c. Well, just to make clear here, c is going to have to be my longest side, so it's got to be bigger than 9.32. But another thing to make note of, so you know if you're getting the right answer or not, is that it can't be any bigger than those two added together. It actually has to be smaller than those two added together. So c is not only going to be bigger than 9.32, it needs to be smaller than 14.32. So keep that in mind when you get an answer. Because if you get something like 18, 19, 20, you made a mistake somewhere. Okay, move the screen around here a little bit. Extend page. All right, so I need to get c. Don't use the rounded answer unless you absolutely have to. Here, I'm going to go back to 5 sine 20 over 25 and set that equal to. Now I want to find c. And c goes with the 103-degree angle. So I do the exact same thing, 5 divided by sine 25, and multiply that by sine 103, and that equals c. If I'd been thinking ahead, I could have just left 5 divided by sine of 125 in here, or sine of 25. I could actually bring it up, second enter, second enter, second enter. There it is right there. I don't know if that saved me much time. Enter, and then I need to take that times sine of 103. So that one's 11.52. Like I said, that should be the longest side. It is the longest side, and it's also less than 14.32. So 11.52. Was it 5.2 or 5.3? Let me double check. 5.3. 5.3. Wrong correctly. Okay, that's using the law of sines. Those are both pretty straightforward when we're trying to find a side. It's a little bit trickier when we need to find an angle, which takes me to the next problem. So I'm going to try to draw a picture. I got a 4, I got a 5. Which one should I put down here? I'm going to put the 4 down here. Not because it's smaller or anything like that, because angle B connects to it. I'm going to try to draw a 28-degree angle for B. And side B couldn't have connected anything, so that's why I started with the 4. Now side B is 5, and 5 it looks, I don't know, it's a little bit longer than 4, something like that. So I need to take this and I need to move this so that it's connected here, and then connects to that little line I drew. So actually, right about there, that looks something pretty close right there. Yeah, well, nobody's perfect. It's going to look something like this. And this is angle A, because it's across from side A. This is angle C. This is side B, which is 5. You need to find side C later on. What relationship do I know? I know that there's a 28-degree angle and that there's a side that goes with it. So I'm going to be using the B's to find the A's and the C's. Well, I don't know any C's. I know A, so I got to use that. I need to know angle A. So I'm going to put the angles on top. I'm going to go sine of 20 8 on top of this one goes with 5, and then sine of A goes with 4. So I didn't have to put the signs on top, but by doing that, I made it so that my variable's in the numerator, and that's always kind of nice. So then I'm going to do sine of 28 divided by 5 in my calculator. I'm going to multiply that by 4, and that's the sine of A. So I got sine of 28 divided by 5. Sine 28. You need to close this off right here, otherwise you're not going to get a right answer. Sine of 28 divided by 5 equals, multiply by 4, and you get about 0.38. I'm going to save this one. I'm going to store this one as x in case I need it later. Now this is actually going to go with A, so maybe you want to store it as A. You know, you could say, oh, forget that, forget x. I'm going to store it as alpha A. From now on, that goes with my A. Okay, so I've got 0.38 is sine of A. I don't want sine of A, I want A. And I showed you in a previous lesson that in order to go backwards, in order to find an angle, you do inverse sine. That cancels this out and gives me A. So I need to do the inverse sine of 0.38, but I'm not doing the inverse sine of 0.38. I'm going to do the inverse sine, second sine of. I could do second negative because it's the last thing I punched in. Or I could do second sine of, I let it be A, and I should get the same thing. Okay? That is angle A. So I'm actually going to store this now as angle A and say, all right, this is angle A. So I'm going to go alpha, oh, hang on a second. I'm going to store alpha A. From now on, there's my angle A. It's in there. I'm going to write it down as 22.06, but it's really not 22.06. All right, so I got 22.06 for angle A. That's degrees. I got 28 degrees for angle B. I can now find angle C using supplementary, or using the fact that we've got 180 degrees in triangles. So I can go 180 minus, there's a 28 degree angle, minus angle A, which was the 22. We got 129.94. That's angle C. I could save that as C. Oops, I forgot to hit store. Let's do that. It's store. I gotta have to press enter again, I do believe. Enter. Okay. And I want to store the answer as C. So from now on, my C is actually C. 129.94. And that's going to allow me to set up to find side C. Okay? I want to continue to use the givens, the ones that are precise. I want to find side C, so I'm going to go back and say 5, side of 5 over sine of 28 is the same thing as side C over sine of 129.94. And we do 5 divided by sine of 28, and multiply that by sine of 129.94, and that's going to be my C. Five divided by sine 28 equals, I'm going to multiply by sine of, I let C be 129.94. Should get about 8.17. 8.17. That's side C. That's the law of sines. Now, this is all I went through on the day one of law of sines. I saved example 3 for the next day in the year 2015. I'm going to go over this one right now, though. Okay, so anyways, we got this last problem here. This one is a little bit of an issue. You might think, oh, well, what do you mean? I'm just going to put this 5 down right here. And there's that 28 again that we had like that. And then I'm just going to go ahead and put a 4. You know, guess what? You could have a 4 going this way, or you could have a 4 going this way. So there's actually 2 triangles, which makes this an ambiguous situation. Which one am I asking for? Am I asking for this one right here? That's this guy. Or am I asking for this one right here? So that causes an issue. I'm actually going to find both. This is 28. This is 28. This is 5. This is 5. B is across, so this is 4. This is 4. And let's see what we got from there. Is the work the same? Well, I know 2 sides and 1 angle on both. So I need to find an angle. So I'm going to use sine on top. I know 4 goes with the 28, so I'm going to go sine of 28 equals. And then 5 is A, so I'm going to find A. This was B, right? This is B. This is B. This is B. This is A. And this is A. Alright, so I go sine of 28 over 4. This over this. This over this. It's the same setup. Equals. And then I want sine of A over 5. And that's going to get me A over 5. Oh, wait a minute. It's the exact same setup. That doesn't make any sense. These are 2 different angles. How in the world am I going to figure out those 2 different angles when it's the same setup? And that takes us back to our unit circle. So first, let's go ahead and find what the calculator gives us for A. So I'm going to do sine of 28 over 4 times 5 equals sine of A. The same work I did up above. It's just I switched the 4 and the 5 around and made the other one A and the other one B. Okay, so let's plug that in again. Because I forgot what it was. So it's sine of 28 over 4. Sine 28 divided by, well, we got to use 4, so that was different anyways. Multiply that by 5. And that equals a sine of A. I'm going to save this. I'm just going to do this as, I'll do this as an A now because I'm doing sine of A, so I'll probably change it again later. But so sine of A is 0.59 approximately. So sine of A is about 0.59. So how do I go backwards to find an angle? What do I got to do to find an angle? A second, give myself a little bit more room. That's where I got to do inverse sine. That cancels that out. I'm going to do inverse sine, and I save that as A. So I'm going to do second sine of A. By the way, this inverse sine, you might also see this down a line called arc sine. It means the same thing. So if I say arc sine, it just means do the inverse sine. Okay, where's my calculator? Lost my calculator. There it is. All right, so I got to do second sine of A. Second sine of alpha A. 35.93. I'm going to save that as my A now. So that's angle A. 35.93. Well, what's 35.93? Got 2 triangles. One of them has 35.93. Which one does it have to be? It's got a mind of its own right now, people. Sorry, it will not stop. I don't know what to do. Okay. So I lost track. What was what? Oh my Lord, it's Friday. It's Friday. I see, 35.93, okay. I got this one and this one. Which one looks like it's 35.93? Well, hopefully you're saying it's this one. So this one will have 35.93. Well then what's this one? That's where we go back to our unit circle and realize that if I got a 35.93 right here, which has a sign of whatever it was, I lost track. Sine of 35.93 was point something or other. Well, remember how I divvied this up and we found a reference angle? There's an angle over here that's 35.93 away from the x that has that same sign because sine has is positive in the first and second quadrant. So you're going to get that sign for this angle and you're going to get that sign for this angle. Question is, what's that angle? Well, that angle is 35.93 away from the x. It's 35.93 short of 180 degrees. So what you need to do is take 180 and subtract 35.93. And that's what this one is that we're looking for. That's that obtuse angle. That's the trick that we need to follow to come up with an obtuse angle. We need to realize the unit circle has sine positive in two spots, negative in two spots for that matter as well. So I say this is if I do 180 minus that angle, that's really what the other triangle has, 144.07. So this angle A is 144.07. Okay? The rest of it is no different than what I did in the first two examples. You can find the other angles. You can add these up here, take it away from 180, you get that one. Add these up here, take it away from 180, you get that one. And you do law of sines to finish it out. So I'll let you tackle that. This has gone lengthy enough. I just wanted to show you that you got to be careful. If you end up where you could actually make two triangles, you're going to have to realize that that unit circle provides you with the other answer. And use 180 minus the answer you find in your calculator. So, well, thanks for watching. You have a great day.